we have 6 practice sectors. The biggest one is structural engineering, which is probably about 70% of our work, and skin sustainability performance. All are pretty new. I want to say less than 5 years old, and and then we have construction support and property loss as well. Property loss services. We work a lot with insurance groups, kind of looking at earthquake damages, and Sandy was a big one for us in New York. And construction support services. It's been around for some time, about almost 15 years now, and we work a lot with fabricators, kind of taking the structural analysis models and then fabricating or developing a Tekla model and detailing it to the level where it can be fabricated. And core, so I never know really, this is the second time I think I talk about core right now. So we have a group called Advanced Computational Modeling Group. It's been around for maybe 2.5 years, and pretty recently we changed the name of it to be core as a combination of computation and research. So so one half is advanced computational modeling, and then one half is the firm-wide research studio that we have, which we founded maybe almost a year ago now. And the idea of the firm-wide research studio is that we have, it's kind of like the Google 20% idea, that we have a certain budget in the firm, annual budget, and we dedicate that to any employee who comes up with a good idea can basically take some time and some money and follow some research ideas. And then the ACM group, which I said has been around for 2.5 years. At this point we're up to 15 people, and we work with all these 6 practice sectors. So we're not just part of New York, or we're not just part of structure, for example. And we do a lot of automation, a lot of kind of software development, a lot of the advanced parametric modeling, and all that kind of stuff. I just got back from San Francisco this morning. We opened a new office in San Francisco. We have our office opening party next week, and we in the elevator lobby we installed a new ceiling sculpture that me and a colleague of mine, Justin Adone, who used to work in Chicago as well, some of you may know, we designed it and built it in the last few days. So this is a rendering, and then this was last night when we had finally installed all the panels. And it's pretty cool because it's a kinetic sculpture. So we have all these like little arrays of servos sitting on top of the ceiling, kind of reacting to people walking underneath and forming really nice patterns when it's static or when it's empty, but then kind of responding with chaos when people walk underneath. So it should be pretty cool to see that. I haven't actually seen it work yet because I had to leave this morning early, but Justin uploaded the software this morning after I left. So let's see how it turns out. So ACM. Otherwise, I guess kind of the reason why we started our group was because, as I had mentioned, with construction support services, we've been working a lot kind of towards the later phases of the project. So we've been really good with BIM and BIM to fabrication and all that kind of stuff. But our focus is really to try and connect more with the architect at the schematic design phase, so that we really want to use kind of some smart computational tools and really some smart workflows to embed as much of maybe our engineering knowledge into the design as early as possible. So I'll show one or two examples of what that means. So this is the culture shed in Hudson Yards, in the Hudson Yards area in New York. Delos Cofidio is designing this, and we are the structural as well as the facade engineers. And it's essentially one big, I don't even know, super truss or something like that. So it's basically it's about 17 stories tall or so, and we have these very large ETFE pillars. They're actually going to be the world's tallest, the world's largest ETFE pillars when they will be finished. And this is a kinetic structure, so this thing moves, and the doors will open kind of dynamically, so it can transform into different kinds of exhibition spaces. And pretty early on, we were involved kind of helping our structural engineers to maybe figure out some of the geometry and just looking at steel warpage criteria and understanding, starting to talk to fabricators and understanding what the, at what point does it get really expensive to fabricate this kind of steel, and how should we modify the geometry in order to avoid that. And then a lot of, what our engineers are doing is already at the schematic design phase, running some finite element studies to understand the node forces, etc. So there was this one point when we realized that the steel was too bent and it was going to be too expensive to fabricate. And so we went back to the drawing board and over the course of a week just came up with all these different variations of that one idea of just using planar elements. So something like that, for example. So here, you can see we're also designing the kinetic structure itself. We actually hired somebody who used to work for a bridge design company, kind of specifically to do this. And as we're designing the structure, and this is really, I think, where maybe our group comes in handy in our firm. As we're designing the structure, we're also designing the facade, and we're also designing the sustainability, kind of the facade Frit pattern of this building. So, so obviously, this being a translucent facade, there's going to be far too much heat gain, and so so the architects were kind of interested in having a Frit pattern limit some of the radiation falling into space. And so we used some of the tools that Mustafa will show in detail a bit later on, Ladybug and Honeybee, to understand how to design the Frit pattern in order to limit the amount of radiation and still have a good amount of daylight falling into the space. And as I mentioned, as we're doing that, we're also designing the actual fabric itself. So it's a really interesting project from that perspective. It's kind of looking into fabrication of the steel, as well as Frit pattern design, as well as kind of fabric design, just to give you an idea. And other than that, we're really kind of always looking at strategizing and optimizing workflows. So I want to show this. I don't usually show this, but this is kind of, this was some research that we did when we taught a class about a year ago at Stevens Institute in New Jersey with a friend of mine, Gregor Wilkner. And the idea was, what if we had, so kind of the problem statement for the students was, imagine we're in the future right now, it's like 2070 or so, 50 years from now, and we're running out of land to build on, and so we're starting to build cities in the water, and we build these kind of big floating pods, and as the population grows, the demand for energy grows, and we need to kind of build more energy plants on demand. And so we set up this kind of automated, we call this thing solar monopoly. This was just a class concept, and we taught a lot of programming in this. And so we set up this kind of database in the cloud where we said, okay, what if the mayor would automatically request proposals and say, hey, we're reaching capacity, we're 80% full now with our kind of demand, and we need more power plants. And then that automated request would, would then just call a web hosted or like a server hosted. In this case, we were using Grasshopper, just kind of Grasshopper script that said, okay, I'm going to come up, every student would then just come up with a different way of designing these solar plants, and then it would upload all the designs, and then the Department of Energy would automatically verify them. So this was all done using XML, kind of a typical language, and then the Department of Energy would just look at that XML code and reverse engineer it to make sure that we have in fact enough cables and enough solar arrays, et cetera, to support that proposal. And then there was an automated bidding request, a bidding process, and the winner would then also automatically, on yet a different server, create a Revit file and upload an IFC. So this was just kind of a fully automated workflow that the students developed, just kind of based on proposals. It would automatically design it, analyze it, and then create the construction documents. Anyway, it was pretty difficult to show this in a video, but basically we did this on top of SharePoint, and basically all these different instances are talking to the same SharePoint database, kind of independently of one another. I'll skip this point. So kind of internally looking at BIM workflows, when people talk about BIM, they always just talk about Revit. We really think it's not just Revit. It can be any kind of information, really. can be site photographs or hand sketches, or a lot of engineers use Excel. So the typical kind of project timeline is we go from SD to DD to CD, and typically what happens is there's always a problem at these intersections. So we kind of work until we have these like 5 nights of deadline, or 5 nights of sleepless nights before the deadline, and then we just produce all this data, and then we kind of just dump it there and we don't look at it again, and then a month later we pick up again from scratch and do that same thing again. So this is kind of the effort curve where it's just work like crazy, and then we don't touch it anymore until much later. So in an ideal world, this would be a lot more linked, where all the information that we start to produce over here will just grow over time into this holistic database. So if we just look at one phase at the time, design development, for example, the ideal workflow would be fairly linear for us as engineers. It's the architect gives us geometry, or we generate the geometry, then we analyze it, and then we document it. But the reality is that by the time we're halfway done documenting it, the design changes or the analysis gets updated. So usually, I'm sure everybody knows that. Everybody currently is kind of trying to tackle this, Grasshopper on the left and Revit on the right workflow, and there's always this kind of disconnect. As soon as we make some changes here or create some drawings there, whatever happens next doesn't update the drawings anymore. And so we don't like to treat this in a linear fashion. We like to treat this more as a we like to think of this more as having kind of a central independent file format. We call it GTX. We came up with our own. It's kind of I want to say a lighter version of IFC, but it's pretty different actually. And the idea is that we can talk to it from our 6 main structure analysis programs that we use. So Grasshopper and Revit is in the mix, as well as Tekla for fabrication, and then also RAM, ETABS, and SAP currently for analysis. And so the idea is that you can kind of go, you can start a project somewhere, you can then update the database, then you can read it somewhere else, you can make changes, and then you can update the database again, and update the first project. So here we just have a really simple model in Revit, and we push it over into Tekla, going through GTX, and then in Tekla we make some changes, we add some elements, and then we can update the database again and later on the model. And so it's basically, it basically keeps track of the elements that have been added or removed or changed, which is really nice, which is really powerful. So I think for the longest time we've always just kind of had these one-way dumps of information going from one software to another. But then once you make a change, you can't update it anymore. So and then another piece of the workflow is also where maybe we start something in Revit, and if you go to the next slide. In Revit, we have, in most of these tools now, we have this kind of connectivity checking tool. The model may look good just the way that the BIM modeler built it, but if you really wanted to create a fabrication model from it, or if you wanted to create an analysis model, we would actually realize if we run it through this checking tool that some of the nodes are disconnected. And then, in a different software, for example, in this case, in Grasshopper, we have a kind of a connectivity fixer that lets us then clean up the model, and then later we can push it back into Revit. And we can actually see, this is what it looks like on a taller tower that we've used the tool on before. So it's really powerful because it's just kind of a quicker way of cleaning up the model so we can use it for more kind of strict applications. And another example is where we start a model in one software, and then you go into 2 different packages in parallel and you do your thing, and then later on you sync them up again. So in this case, we started a truss in Grasshopper, and then we pushed it through GTX into Revit and SAP. And while we are laying out the documentation, kind of the drawing and all the views, and setting up all the the sheets with all the different tags, etc., inside of Revit, we're actually running the calculations and sizing all the elements, the real sizes in SAP. So these were just kind of dummy sizes when we brought it in from Grasshopper. And the nice thing is that you can then later on just update the drawing. So all the downstream information that is tagged onto the model, in this case the views and the tags, etc., will update once the model updates. So that's really powerful because that really means that we can take the documentation set and we don't have to redo it over and over and over just because something changed in the design process. For for the guys at Case, I'm sorry to bore you. I showed this already at Autodesk University. We were talking earlier that there has to be something new in this presentation since 2 months ago. So 2 months ago, we also introduced the idea of TTX apps. So we have, for example, a query system now. So the nice thing about TTX is that it's based in a. I think it's going too fast for me. I think I want to control my own speed. Okay. I feel like I'm like. On a,
Anthony told me like.
Okay. So the nice thing about TTX is that it's built in a database. That means we can just keep growing it over time. And so as we are kind of growing it over time, oh, sorry, I'm just going to stop here. So you know, the thing is that it grows over time, and so we can kind of keep track of what happened in the past and what happens next, etc. And also, what is really nice is that it's not just a geometric or not just a BIM database, but we also are actually transferring analysis data. So we actually know all the stresses acting upon in all the members and in all of the nodes. So we can now, you know, SAP may be good or ETABS may be good to run the analysis, but it's not really good to create a report or to have a structural engineer kind of run through the whole model and really understand what forces are acting and what members. So we created this kind of query interface. This is in Grasshopper currently, where we can then filter views, and we can say, hey, show me all the elements where, you know, the forces are greater than, I don't know, 200 kilonewtons and smaller than something else. So it's kind of in between a certain range, which is really powerful, and which is something, you know, then we can kind of zoom into the areas and see where we under-designed something, and we can change the design. And another really powerful feature is version history. So we actually know, oh, it's not the right video, there it is. So we're actually kind of mimicking GitHub. For anybody who's maybe familiar with programming, GitHub is kind of, I want to say, maybe it's a bit like Google Docs. So it's kind of it's an open source kind of shared coding environment where you can start a project and somebody else can make a change, and they can let you know what change they made, and then somebody else, you know, can again maybe change it a bit and upload the latest. So basically, when we go through the different TTX revisions, we always record the timestamp, we record the author, we record a comment, so the author always has to say what they actually changed, and then we also record the program that made the change. And so that means that we can then later on go back and look at this database of different project iteration instances, and we can compare different instances. So we can say, hey, what happened between, you know, May 10th and May 30th? Or we could say, well, whatever we had like in April was actually better than what we have now. So let's just revert all of our models and documents back to what we had in April. So you can kind of go back a couple of iterations and you know, update all your models, and then all the drawings will be updated as well. So it's really powerful because you're not just designing in one instance in time anymore, but you're recording the whole history, and you also can compare notes in between. Okay, so I'm going to press the button every 5 seconds.
Yeah, you can do that. This one is gone. So this is what I do in the office, basically. I'm part of the core, but I work with sustainability team, the STEAM team. I do so much of parametric environmental analysis, workflow development, and software development, custom software development, in a way that we can help the workflow. Okay. So, and then like after after hours, during hours, some kind of. So I also develop open source software for environmental analysis. Ladybug has been around for a year. These are all plugins for Grasshopper right now, but we're moving to the other platforms too. So there's one, Ladybug, has been around for a year now. Like, it does the weather data analysis. Honeybee, that logo is old. Honeybee is not yellow. I'm sorry. Like, now it's brown, but Honeybee does run daylighting and energy simulation. And I'm working with the Penn State University. I want to make sure everybody heard Penn State, because I said something and somebody said NSA. No, Penn State. So I'm working with Penn State University on an open source project that we call it Butterfly, which will make you able to run outdoor CFD analysis. So this is the you know the dream. You have design, evaluation, optimization, and you go next. Is okay, we do all this stuff, right? You know, like when I say as an engineer, I feel weird because like last year, if you met me here, I was an architect. So as an engineer, the question is like, okay, so you're doing all this stuff, like it's cool. We're trying to help our workflow inside, but like what we are doing for the industry, or how we can just think like of moving the industry more than just doing some stuff in-house, you know? And then it comes to the point that you think, okay, if we want to make a difference, we should try to move the whole industry together. And then the question is how we can move the whole industry together. It's just like, okay, we should start helping architects and designers to get into what we think, so we can just do it together more. You know, like when I released Ladybug, the idea was like, okay, you make this radiation analysis as simple as everybody can run it. So radiation analysis is not going to be a big question anymore. So next time they come here, you can talk about daylighting. You know, because radiation is done, it's simple, it's not that hard. You can start educate yourself with that. And next of all, I just released Honeybee, and like we're doing workshops here. And I hope like next time we talk here, people know about the basics of daylighting, so we can go talk about energy. Next time we can go talk about controls. We can talk about real optimization in a way that everybody knows what we're talking about. So having this idea is always a question like, how do you teach designers about simulation workflow? And the answer so far is, next slide. You don't. You teach simulation workflow about designers. And the result of that is, next slide. I just take 3 seconds. Yeah, and when you do that, the designers will start catching up. And these are those examples from my emails that I found just like the night before. And he is telling like with the watch the sky component, I have a better understanding of different skies. Great. And when I see something like that, I just write on. So I want you to know there is a sky when you run a daylighting simulation. Probably you never noticed, you run it and it gives you some results. So there are skies, there are different skies. Or the other one is, you have always, this thing has always been around, like, yeah, designers don't want to learn, they don't want to learn anything, they can't do energy analysis because they don't know what it is. So you get this kind of emails that somebody says, I mean, the blaming part is something else. He wanted to blame me, but it wasn't my fault. But then he said, like, I need to say that my experience with DaySim is not that good, but I expect to build it, to increase it with Honeybee seriously. I will make it up, even with Energy Plus with you if needed. You know, you start to see, okay, you change the way the workflow is with simulation, and now you see designers start to get used to it, and they start, I get like crazy questions. People do crazy stuff that I could never ever imagine designers even think about it. So the next one is, yes, a little bit about Ladybug and Honeybee. I don't know like how many people here use Grasshopper and know about Ladybug, but Ladybug is a next one is a like a weather data and visualization and analysis plugin for Grasshopper. You can go watch the video. We don't have time. Anthony just told me. But like why I did that is mainly like why I did, as I said, the first one was awareness. I really wanted people to know more, especially designers. I want everyone to know about basic stuff. I didn't want some SPL like a really crazy stuff to think about it. I wanted you to be able to do like draw a SongPass for any place at any time. Make it easier and faster. Make it more integrated to the design, and make more people capable. And this is another sign when I feel good. It's just like what used to take me a whole painful day in some software now happens in no time. Basically, this is the best thing ever. Let's go next. So this is an example. Like I always show SongPass because I think SongPass is my favorite component there. And I think it really represents what I said, that you don't teach designers about simulation, you teach simulation about designers. So usually, like, we see SongPass, but like the point that usually is missed is SongPass is hourly data visualization. The only difference is just like you present the position of the sun for each hour. So if it's an hourly data visualization, I can integrate it with other hourly data visualization that I have from the weather file, like radiation and temperature. And when I have radiation and temperature, similar to the queries like we are running for TTX, so I can say, show me the sun positions for when the temperature is more than 28 and the radiation is more than 630. That is basically when I want to have shadings. And when I say that, the sum pass goes and find the sum positions that is actually like satisfy the conditional statement. And because it's in Grasshopper, I already have the vectors. You just connect the vector to the shading designer, it designs the shading. I don't know if, like, when I was in school, like, calculating HSA and BSA for designing it was like the catastrophe. I was like, I can't stop my design, go calculate HSA, BSA, come back, okay, this is my shading. Like, you know, so this kind of thing I think is going to change. Basically, this is a new way of collaboration and it's a paradigm shift. This is like how the sky looks. Let's go to the next one. Radiation rows. This one hopefully like is going to replace that cubes that everybody runs radiation analysis and say on the south is red, on the north is blue. Yeah, we know that. So this one basically shows how much radiation you get from different directions, and now you can integrate it with your site. So if you have multiple buildings and you're starting to design, let's say this circle is basically your radiation budget for your building. Coming like somebody, you're working with an engineer and they tell you this is the radiation budget that we can get on this facade if we want to meet this number for the heating and cooling. So you can look around the place and see like how are you doing right now and what is going to be different strategy. So before even drawing the line, you get some ideas about how you want to design. Next one is going to be, and this is some kind of a stuff that I didn't think people do, but they're doing. So this is like they use the Ladybug components to do like a visualization inside Grasshopper. This is the work of Chris Mackey when he was an intern at TT. And yeah, definitely you can do the colorful stuff too, like if you want. But then I was thinking, look, okay, now this thing has been around. I was thinking like maybe something that in the next level that you can run energy and daylighting simulation. And I was calling it Honeybee, and it's supposed to be there, but it started to be like even more components than Ladybug, so we just moved it over. And this part is not available, which is Energy Plus and Open Studio. But for the rest, you can go ahead and it's on GitHub. You can just download it from Grasshopper group, and if you want to use it. And so far it works during the last 2 days. So this is the workflow diagram that it was the idea, and this was like the first time that I was getting it right. And this is for energy simulation. So the concept is you have a mass, you just create some zones, you add the glazing types, glazing sizes based on the percentage, you run the energy simulation, you can bring the model back and visualize the result. If you go next, the other thing that it does, so the version that you have out right now is running all this stuff that I can say, like running something with radiance, like the shadow study or something, is something that still in this industry people talk about it like magic. You know, like it's so simple. Everybody should be able to do that. We shouldn't, like, I think we shouldn't get any contract to do this for designers. Like, you should do it. Like, you should have a better question for us, so we can work together. You know, like there are something that you can watch the sky. There are some components for glare analysis. I made like basically Honeybee right now. If you know how to use it, you can do really advanced stuff. But I made it hard in a way that if you don't really know DaySim, you will get just errors and warnings. So you can't really run it. I'm taking care of that as far as I can. But I know you will find a way. So this is another example of like if you get Honeybee and if you know how to use it, this is actually a real project that we're doing at TT, and I use the similar components to run like a parametric analysis for the glass type. This is only a single slide for this, just to show what you can do. And this is another example that I have for how you change the workflow to work for designers. All of you know about like annual run, like annual, many of you know about annual daylighting simulation probably. And when you run annual daylighting simulation, usually the values that you get is something for annual space. For example, they say daylight autonomy of this space for 300 lux is 65%. And say, okay, what does it mean? It means like for the 65% of the time, you get enough daylight in this space for these test points or whatever you have. And then you say, okay, is it good? And then someone says, oh, okay, this is normal, but we want to get to 75%, and you're the designer, and I'm like, okay, what should I do? Oh, like 75 versus 65, make it 75. And you're like, okay, what should I do? Like, just as a designer, so you can't really follow and see why this is 65 versus, and it's not 75, or like, what's happening here? And this is like a kind of a simple component that lets you go through the result for every hour of the year. So probably at some point you think, okay, why am I getting 65% versus 75 that is possible. Is the window size, is it happening for all the sides of my building? What's happening? Is it like, is the problem during summer or is it during winter? So it gives you like these options of going and like, because you already ran all this annual analysis, why you shouldn't have access to the data for each hour. Again, I think like, when you talk about it, it's just so simple, but when you use it, it just changes the way you work. You can go for the next slide. And yeah, if you can get it to work to what you want. So I opened up some part of the DaySim that I don't know if it was available through the interface before. I think it's available from the DaySim that they're developing at Penn State University. So what you see here is a dynamic blind simulation. So the client had the question of should they use the dynamic blind or not, and is it going to be helpful or not? So we used DaySim through Honeybee to basically simulate the effect of using the blind. And what is important for the dynamic blind is you should be able to predict the behavior of the user. First of all, to know like when they're bringing the blinds down, when the blind goes up, and then find that relationship with the lighting inside the space, so you can potentially, using DaySim, say how much electrical use you will have. I mean, it doesn't calculate the right electrical use, but it's really helpful. And I think like to run something like this in like earlier stages of design, be able to visualize it like this to the designer for everything is something really helpful to just make the discussions. And we know, you just press play, and we know that not everyone is good using Grasshopper and Rhino. However, we start with that. So now like Dynamo is getting over, and I used it like 6-7 months ago, and we opened it up in the office and like check. No, I'm not gonna use it. So then I check it again later on, and it really works. So now that it really works, they have the Green Building Studio as the backend, which runs on top of DO2. So what we're trying to do is like something similar to Honeybee for Grasshopper. This time it's happening for Dynamo and Revit. So that's the family. I'm changing like the floor height. It's similar what you can do. So you can just bring your family and then set up your parameters that you want for your energy model. Like they call it energy setting in Vasari Revit. So you can change the glazing percentage. You can change the shading depths. You can change the HVAC system that they have. All that stuff. If you want, you can change the schedule. Then you say set it to true. It gives you the energy model. And you can write the GBXML file. You can send it there. You can run the analysis, get the result back. We haven't worked on the getting the result back or something. Just this is basically a work of like an afternoon or something to chase the job. So next one is okay. So this is a diagram that I think this is something I drew like 8 years ago, I think, or something. And I'm showing you like in every single presentation after that. When I'm talking about environmental design and analysis, you can add it to everything. But this is how I think like during the process of design process, if you have like a pre-designed only program, then conceptual, and then the detailed design, the way you look to the problem, the way you want to run the study, the questions that you ask are different. But like the process that you should go through is almost the same, which is that circle that you should recognize the question. You know what I'm talking about. Usually, like you run the analysis for the question, which is not the real question of the project. You put all the time you have the answer. So this wasn't the question. So then, when you recognize the question, you should be able to define the strategy. When you define the strategy, all the painful process starts for creating the model, calculating the performance, calculating the simulation, and then getting the result visualization. I think all the development that we're doing like now helps with that part, the red part, the simulation tool. But then it comes back, okay, I ran all this analysis, I have 2 gigs of data. Awesome. What to do with it? I have no idea. So that's the problem. Like, okay, you get all this data. Which kind of data you want to use that? What's the use of that? And if you be really, really the good one, you can modify your design based on the energy analysis or daylighting analysis or any analytic analysis, and then you can come up with a new idea that works better. So the question is, okay, we help with that tree. What are we going to with number 1, 2, 6, 7, and 8? And here you go remote solving. Before that, like I forget this. Like this is another slide that I use so much. So do you guys know about this one? Technology pipe, they call it. So this is the way it works. You get a new technology, you get excited, solve all the problem of the world. You're on the Time magazine, like cover, all this stuff. Best. For me, I did like, yeah, Ladybug came out, wow, this is amazing. Tomorrow, like, I have an atrium, like it's 4D floor height. I have 4 different openings come to it, and we want to test natural ventilation. Can we do it? No, you can't. Boom. It's useless. You know? So the question is like how you can help, even like after doing all this stuff, how we can help each other. And I think kind of the industry go up to this plateau of productivity. These things are awesome. We get excited about it, like, and I think we are getting like really good. All the industry are talking about getting excited about stuff and putting out there and just talking to clients what we can do. And like, but many things ends up there. It comes here, and from this line it drops down. So the question is like how we can push it forward. And we think the answer to that is support. Like how we can use this computation environment that we develop, all this collaboration, and support the designers through this process while don't blocking them from what they want to know. And this is what we call remote solving.
Yeah, so maybe about 2.5 years ago now, we started this. At the point, it was a research project that we did with LMN Tech Studio up in Seattle, and the idea was that, hey, you know, more and more of us are starting to use the same platform. I mean, this was really kind of based on Grasshopper. Like, I gave a presentation, they gave a presentation, and then we're like, whoa, we can do the same stuff as architects and engineers. And then we went to the bar, and then we came up, you know, after 2 beers, with kind of this idea that we call remote solving. The idea that what if we set up that kind of computational kind of project or workflow in a cloud somewhere where all parties can have access. So, for example, you know, architects can have access to the design inputs, and then engineers and contractors can give feedback. And over time, maybe based on the feedback or based on the analysis or based on the varying design inputs, they can make changes to the you know, computational model. So it's really the same thing that happens in a project. Week after week, we get new drawings, and the design changes, and then we have to get feedback. But this just, you know, this just happens in the cloud, and it's a lot faster than having these kind of 2-week increments of you know, basically the architect giving us something in a DWG file, but we would like to have a 3D model. But you know, when they give us a 3D model, then the connections don't work, and so we have to rebuild it. So let's just set it up so that whatever modifications they make to the geometry, you know, it's already set up for analysis as well. So yeah, here's a nice diagram that we made with LMN. You know, if we start in the top left corner, so you know, kind of the schematic design phase again. The architect just kind of starts with the massing model, then gives that. This is kind of the ideal workflow. Gives that to the structural engineer. They lay out maybe the grids and then the columns and beams, and then calculate all the sizes, and then based on beam depths, you know, based on the ceiling depths, they can then write daylight studies, and then give it to an energy consultant or a mechanical engineer to run an energy analysis. And ideally, all of this will happen, you know, kind of structure informs daylight, informs energy, informs the overall building. So all of this will happen ideally in, you know, one design iteration over the course of one afternoon or one hour. But really, it never happens because we aren't organized enough. So what we do is more kind of this linear workflow where, you know, we're given an iteration, and then by the time we're done processing it, the design has already changed, and so we don't really have that much of an impact as engineers in the schematic design phase. But ideally, we'd be working much more hand in hand. So it's kind of pretty simple. So you know, like I said, this was kind of a proof of concept where the architects are controlling the master model, and then we have a server set up somewhere, and basically it just writes the geometry. Every time the geometry changes, it just updates the database on the server, and then our Grasshopper model is running in the cloud and it's just reading the latest geometric information. It's running the structural analysis. It's sizing all the columns and beams, and then it's also calculating embodied carbon in this case, and it's giving back that information. And so the architect can instantly understand, you know, what kind of an impact they have, that current design iteration has based on embodied carbon or embedded energy. You know, and this takes like a couple of minutes or so to go back and forth. Do you want to do this?
And then we started like getting another project because this is a real project that.
Yeah, I should say this was like, you know, like I said, about 2.5 years ago, and we've presented that idea many times, but
the free pattern, what type of free pattern we want to use. And they had a big image in their mind, like, we want to look this versus that, which one is a better idea. So the typical workflow is just I go and say, okay, send me your ideas that you have. I'll get that. I run something for you. I'll give you a report. Then we can talk about it. If you want to change it, send me another one. And then we can go over. And if you want to send me 10, I don't know, like, it's up to you. But then we sat down and said, like, why we should do that? Why we just go and use remote solving? We know what is the problem. We already talked to each other about that. We know what are the limitations, and we know your language, you know our language. So we take over the part of analysis and we automate that for you. And you're going to give me an image for like making all this stuff, just upload it to my Dropbox. So we just had a folder shared on the Dropbox, and the idea was like, okay, these are the images that you want. Just this is the structure of putting the image. For each facade, put this image, and this is the name. And then you say go. And when it says go, it comes into our system, and then we just get the images, we push it all around the building, wrap it around, and make it look to the graphic that they want, create a daylighting analysis out of it, and run all the daylighting analysis on the cloud, and give them a report, which is not only an image, but there is an Excel spreadsheet there too that they can see all the values for all the spaces. So basically, we are giving them the freedom to test something, get it back, look at it, it doesn't look good, and then play with it. And the idea of like let them play around to start educating themselves. And definitely we can have our hidden support in checking the stuff. For this project, we didn't do that. But like the good concept is like while this thing is running, we can even hint them about something that they're doing wrong. It's just like working with someone to find the same language, and at the same time, the best time to teach someone something is when they need it. And I think that's happening here. So this is just like two iterations that they ran, and like adding, I think, some light or darker that you can see the glare issue, the potential glare issue goes away from the side. And the cool part is just at the same time, because we have the building scheme group, they can take care of it and just like come up with ideas that we make sure the image that we produce and the analysis that we run for daylighting is going to be really good for construction too at the same time. So we don't end up coming to the designers and say, you know what, this is optimized for daylighting, but I'm sorry, you can't make it because it's 200 different panels. Use this. So everything can go at the same time, and we can make sure that at the end we get some results that is not only looks good, but is something that we can go for the construction. Yeah, these are different iterations and all this stuff. Yes, what is the focus in 2014? Should we go for it?
Yeah, so now it's 2014. So
yes.
So now for us, I mean, kind of going on from that, you know, Dropbox and that kind of stuff, we want to get a lot more into web-based collaboration. And so I don't know, we posted this video on Friday, and we already had like 500 views in the Grasshopper forum. So this is like something that we just started developing, the idea that we can have kind of a live collaboration platform in a web browser. So you know, you can imagine like multiple people streaming their geometry into the same browser environment and kind of comparing nodes very dynamically. So this is a tool that is called Platypus. It's going to be released eventually. I don't know yet when. Soon, I think. And oops. And then also maybe 2 days ago we updated our TT Toolbox plugin for Grasshopper, and we now include a link with Google Spreadsheets. So it's just kind of a small step, but it's kind of, we're really interested in just providing more infrastructure around web-based technologies, and just kind of see where that leads us. And then also on that note, last year we had our first, we call it AEC Technology Symposium last May. It was a pretty big event, actually. We started like just kind of like we wanted it to be something like this, kind of computational gathering, but all of a sudden it was a 2-day conference by the time we were done planning it. And so now it's an annual thing, and it's going to take place again on May 16th. So it will be a full-day set of mainly practice-based, not so much academic presentations, kind of around these ideas. We want to focus on web specifically. And then on the weekend, on the 17th and 18th, we'll host a hackathon where we'll have access to all these tools, and we want people to come with their own tools and just see what we can develop kind of together.
Yeah, and I think like
with that in mind.
We're trying to do different about hackathon. People like, I don't know if you have been to a hackathon ever. But like hackathon is something like usually it's for computer science people. They come together, like, and they start hacking an issue. Like they start get together and say like, okay, this weekend let's hack all the data that you can find for the transit in New York and come up with some idea. Yeah, so you sit together and say, okay, let's hack the data. Let's see if we can come up with the app that helps people to find the right bicycle at the right time in New York. You need that. And then like all that stuff. So, but what we're missing usually in the building industry is not everybody is a person who can code, and we know that. And like you come here, maybe you have a knowledge in Grasshopper, you know a little bit of the scripting. And the idea is we will have leaders for the hackathon to help you doing that. So it's not going to be you starting coding or a line of code or syntax or something. So you come up with the idea, and we will support that idea to really happen if you have the mentality of computational design. And we hope really at the end of 2 days we get something out of it for a day.
2 days.
2 days, yes.
Yep.
Yeah, if you don't sleep.
All right, that's it. Thank you very much.
Thank you so much.
All right. Any questions? No, it's it's very specific to structural engineering. I mean, for example, it wouldn't work with energy models or something like that. It's very much kind of based on stick models right now. So, and we've shared it before in a way that we've kind of consulted with it. So we've developed. There was an architecture firm that were interested in translating slab and facade geometry between Grasshopper and Revit. So we just kind of did that using TTX for them. But we're not going to get it. I mean, yeah, we keep talking about this, but I don't think we'll get into the business of kind of selling or giving away software and then having to have this 1-800 number for support services and all that kind of stuff. So, yeah, the short answer is no.
No. Should go for the drinks. I don't drink. You guys may. Go ahead.
Are you currently doing like single zone energy modeling or modeling entire building?
It does multiple zone, but I have it on my system. I haven't shared that. Like there is and the reason is not like we don't want to share or I don't want to share. The reason is just it's not ready for that level, And unfortunately, there are like 99 ways to run an energy model wrong. If you think about 100, and I want to avoid all of that. I think we have enough like single-click garbage in, garbage out stuff, and I don't want to add one more. So that's the reason. But like back to your question, yes, it does. It does multiple zones. It takes care of that. And there is an idea, like I showed here, Energy Plus. I did a test run with OpenStudio API, and you can do similar thing using OpenStudio. And the other good news that maybe I should mention is like we get hired for the GBXML project as a consultant. And the guy who came to the office for the GBXML project and all this stuff, he saw all this development and all this stuff. He said, like, yeah, let's write the GBXML exporter for Honeybee now. So there will be like a grizzly bear coming out at some point. So you can not only you can export GBXML, so it opens it up to other kind of softwares like energy simulation softwares that you want to use. And actually, I saw an email that somebody is using GBXML for CFD, which was pretty cool.
So what's your goal for the butterfly?
The butterfly runs the outdoor CFD simulation. So the idea is like we don't have a really, about OpenFOAM, so you get Fluent as like a good computational software that you have, but it's so expensive. And like it's not accessible, and it's just like it's in a level that you can't really, you should know so much to set up something. So now the idea is, especially about the comfort, like outdoor comfort and all this stuff, can we make designers capable of running some blocks of a city on the cloud and have a feedback about like how the airflow is going to be. So that's the idea. So you can run Grasshopper, and it's going to be web-based at the same time too. So the web-based project calls it F3 Pulse. If you search for it, you can find it. There's a website for that. And then because it's the same code, I'm going to use it inside as a part of this development, which is going to be butterfly. So you can basically send out your geometry to OpenFOAM, and it will run the airflow simulation. And still, I don't read the result back, but like you can visualize the result on the web, so you can test your ideas. Yeah, that's a part like I really like kind of on hold because of mainly because they can't find enough funds to get good cloud computing. Anybody here can help with that? But you know, because I think like that's and for me it's a little bit frustrating because I'm so much about like developing something, putting it out there, and see what people think. And like the main part of development is actually when you put it out there, people start using it. So we are on hold on that.
The people at Penn State, is that part of the energy efficient building hub?
I don't think that's a separate project.
Yeah, okay, because it's a matter of, do they even know about EEB? EEB has lots of money. They have lots of money, and they actually had a hard time spending it in a way that was making sponsors happy. They were not. So it's a matter of they should take, well, I don't. Yeah, see, they took money away from all the other labs. So for those of you who don't know, I'm at Argonne National Lab. They took lots of money away from all the labs doing building stuff. But it's a matter of what you need to do is talk to those people at Penn State to say, have you talked to the people over at EEB? Because EEB is working with Open Studio Group for integrating some tools, which you may or may not know. And I didn't know that there was anybody who was doing OpenFOAM, but it could be, oh, wow, this is an obvious, we're talking buildings, an obvious connection that they may be able to find some internal funding.
I'll talk to them definitely. Thank you.
I want to see them doing that instead of some of the stupid things they're doing.
So maybe not software related, but certainly computation related. ACM's been around for, you said, 2.5 years?
Yeah, something like that.
How were you able to convince TT to kind of buy into computation as a process that should be touted?
Yeah, I don't think I convinced them of anything. There was a guy before, Gregor Wilkner, the guy that I taught that class with. He was the director of automation for 6 years, and I think I like to believe that he laid all the foundation. So he was, he had only small team. It was at best 2 people. Mm-hmm. But I think when basically he left and I came, and I think there was kind of a big void for a bit. And at that point was exactly when Grasshopper kind of became popular. Oh, so we spent, there was this one project that was pretty cool in 2010 when we basically went to the architect's office and we spent like 3 days and we developed like a parametric model for a stadium and we ran different analyses and we documented it in Revit in the end. It was all like done in 3 days. And then they were like, wow, you can do that for a competition. And then it started like training people, hiring people. So it was kind of, yeah, I guess you just needed to show them once like what can be done, and then it was kind of a self-starter. But our CEO is really, really support. I mean the company as a whole, but especially the CEO is like, he's on the same floor as us. Like he wanted to sit right next to us, so he's definitely supporting all this kind of stuff. Yeah. His son just got a makeup bot for Christmas. So
oh, really?
Yeah. So he's like, and he comes by every day, and he's like, "What happened? I think it broke." Like, and then we need to give him some new stuff to fix his makeup bot. But yeah, so he's like that kind of nature.
Okay.
Which is helpful a lot.
Have you found, as you work with other design firms, that people have been reluctant to not want to use computation? They just want to do it how they've always done it.
Yeah, there's definitely. They can work with whoever. No, but some projects just that you can't realize them when. Some of the buildings. Okay, a lot of the buildings, I guess that those kind of people touch are not that exciting, I guess. Yeah. But like the culture shed or some of this stuff is just, if you don't want to use computation, then I don't think it gets realized.
Yeah.
There was one tower. Well, there were quite a few buildings. For example, the China-based buildings, where we don't have as much control because we handed over pretty early. So we just want to put as much information into the project as possible early on. So we are, for like a doubly curved surface, we want to understand as early as possible, if that it can be fabricated with that amount of single or like code bent panels basically.
Yeah.
So yeah, so I think for the more complex projects, it's really important.
Is the TTX firm-wide standard, meaning does all employees use it, or is it still?
It's young. It's less than a year old at this point, so it's like an kind of beta version right now. We're pushing it really hard. I mean, we have somebody teaching it right now. I think I want to say probably 10 different offices in the spring. We've developed all these kind of videos and tutorials and samples, and it's really taking on. I mean, we've probably used it on 15 projects so far, but it's a big firm, so the goal is to have it on 100 projects in a year. So it's still a small percentage. But yeah, it's really important. I mean, kind of back to your questions, it's really important to have this whole support infrastructure, like having people, like what we have done is, our group is mainly in New York, with 2 exceptions, but we have kind of Eloy and others we probably have about 100 people that have been trained now in Grasshopper, probably more, but maybe 20 of them or so are like ambassadors. We call them ACM ambassadors. So the idea is that they champions, yeah, something like that. So the idea is that in their local, in every office we have at least 1 or 2 ambassadors, and then they keep up to speed with what we do, and they let us know what they do, and so it's really important for a bigger firm to keep communicating.
So I'm curious, do you find that clients come to you requesting sort of intelligent computational design approach, or is it very much going out showing them what you can do?
I can say, I can use the example of this Frit pattern.
Yeah.
So when they came in, the idea was like, can you just run 5 options for us?
Yeah.
And then we said like, why 5 options? You can run like 100 if you want.
Yeah, yeah.
So this is like, it's like, I think in many projects, if we see the potential, we offer it, and I think they like it. Like another example was like we did a competition, like it was early phase, and they were again thinking of like designing I think 4 or 5 options for shadings, and it said if you can run it. It was like they were happy with 2 and said this is the workflow, just run 100. Like and I think like when you do it once, next time they come back and that's raising the bar for what I said. Like so they run that thing, they ask for something better.
Yeah, so you're just like kind of like upload it to our cloud. So what of that, like that sort of how do you call it? Peak of enlightenment. What of these things? What is like the most memorable, or what's been the biggest impact you think on the industry so far?
I think for me it was like, I mean, if you're talking about like only about the Ladybug and Honeybee and all this stuff, there are 2 things that really shows me that this thing works. One is when people talking about this stuff as like really simple stuff. I have been like, and not everybody knows me in person, when you see they talk and so like, yeah, radiation analysis is just so simple, I ran some, So you feel, okay, this thing is working, now it's not a big deal or something. And the second thing, after you see that, I get a question, somebody says, I ran it for 21st of June and ran it for 21st of December, and the numbers look the same, what's wrong? And that's my moment of finally someone looking at the numbers. That's, you can see it's a start to being useful. It's not only generating that email. That's for me, that's just a start. It's not like I don't have that kind of memories walking in the street and somebody says, hey, Ladybug or something, but yeah.
You're not walking down the right streets yet.
Right. Have you in a consultant meeting asking the wrong questions?
Well, that's what we want to happen. And yes, there's so many, and that's the good point. Like that's the moment of showing people what's right, because they have already been through. Like that's the start point. I have seen so much, but I don't get like kind of frustrated or something, because that's what I think like should happen. You should run it wrong multiple times. This is what all of us do, and get to the point of like feel something is wrong, And that's the point you're ready to go to the next level. So next time you're running wrong. I mean, like I did some presentation for the Radiance workshop, and somebody asked, like, you by making this thing this easy, don't you think like people are going to just use it wrong and wrong and wrong over? And like my thing is like what's happening today with having this hard. Instead of using Photoshop, at least they're using the real analysis. You know, they will generate that. You know, just like you can't.
So it's more accurately wrong.
And I hope what I hope is just like when people do that. I mean, like the even for the Honeybee, if you go to the website, I can make a single click installation package for you, but I don't have that. You should go to the Radiance website and download Radiance. You should go to the Daisy website, download Daisy, because I want everybody to know there is a Radiance running all this stuff. So, or there is a Daisy, or there is Energy Plus, so you don't get questions of like, is Design Builder more accurate or Open Studio? And you're like, they're using the same engine, and people are like, You know, this kind of thing is a part of this development that I think is like the main part for me is the educational part. And what I said about like getting everybody on a like higher level as far as possible.
So, and is it correct if you just wrap, like Ladybug, so you wrap for these other engines? Is that?
Ladybug is very conceptual, so I wrote kind of part of the back end too. So I used the Radiance Sky, and for the ray tracing, I wrote the simplified ray tracing. But Honeybee is an interface for Radiance and Daisy, and Energy Plus and Open Studio eventually. Yes, that's right. And many of the components are mainly like, if you see like a big part of Honeybee is result visualization. Because I think as a workflow, it's not about running the analysis. It's about looking back to the result and see what's happening there. So there's so much about that.
Yes.
Thank you so much.
Thank you.